Hi, my name is Mike Saraf. I'm a senior platform engineer at Red Ventures. You may not have heard of Red Ventures, but you probably know of some of our brands. Brands like Bankrate, The Points Guy, GameSpot, CNET, Healthline, Lonely Planet, there's a ton more. I tell you that not just to introduce you to Red Ventures, but to give you some context for this talk. Red Ventures started off with a simple business model. We partnered with companies and helped them market their products online. But as Red Ventures grew, we knew we wanted to start doing this for our own brands. Some brands we would build in-house and some we would acquire. Before we knew it, over a few years, we had a large portfolio of companies, nearly all of which used AWS, and consequently, we ended up with just as many ways for accessing AWS. So this left us with a number of questions and a ton of challenges. First, this was becoming a terrible experience for our engineers. When a new engineer would onboard to the company, or if an engineer would move between different business groups, there would be lots of questions. It would also be a security nightmare because now there were multiple ways to access AWS and so multiple endpoints for them to audit. It also created compliance issues as well. When an engineer would come to us and say, hey, what accounts do I have access to? It was always a, well, it depends type of answer. Like, are you working on the health vertical or the education vertical? Well, you probably need the AWS tile. Oh, it's on the health vertical. Well, you need the Healthline AWS tile. Oh, you're an admin. Well, now you need the admin tile. And that was just figuring out how to get into an account. Then people would ask, how do I get access to the developer role? I would say, well, that's easy. Just go into the Terraform for your account, add yourself to the developer role. Oh, you need like extra access? Oh, you just have to go in. You don't do Terraform for that. You go into SailPoint and request access there. Oh, you're an admin for that team. Oh, you actually need a different tile and you need to have somebody add you by hand to that role. You can imagine it was pretty confusing. And this wasn't really anyone's fault. This was just like the natural result of rapid growth. But we came to a point where we needed to step back and say, hey, we need to redesign the system and solve not just for existing problems, but challenges we're going to face in the future as we continue to grow. So 3 of us from our Central Corp support group formed a team. We researched options. We talked to a ton of engineers on different vertical groups and came up with some product requirements. We wanted overall a better user experience for our engineers. We also wanted a much better and more concise strengthened security posture. We wanted improved visibility for compliance. And we wanted access to remain fast and easy. So we knew we wanted self-service for people to request access. And we also knew we needed to integrate in with our array of third-party tooling, part of which was for IAM and part of it was for ServiceNow. So at a high level, what we have now is a system that has a custom Terraform provider, an API that it calls, and that API then orchestrates the integration, not just with the configuration, but with all our third-party services. So from here, I'm going to hand it over to Austin to dive into the details.
Like Mike said, my name is Austin Burdine. I am a staff engineer on our corporate technology team, and I'm going to walk through kind of how we approached the problem of integrating this solution and how we decided on our final implementation. Before I get into the technical details, I need to go through a few concepts just so everybody's familiar with the terminology that I use later on. IAM roles in AWS are things in each account that dictate who can access what and do what actions on what resources. And on top of that, you have permission sets, and this is a concept in AWS's single sign-on service, which is kind of the bare bones of what our implementation uses. And permission sets, you can think of them as blueprints for IAM roles. When you assign a permission set to an account, it creates an IAM role using the specification in that permission set. We also have AWS accounts and AWS organizations. AWS accounts are kind of the top-level organizational group for resources in a particular project, and organizations are a layer on top of that that organize different accounts into various other groups based on how your organization as a whole is structured. We also have Active Directory groups, which they're pretty self-explanatory. They're user or groups of users that we assign then to other things to dictate who can access what. We also have ServiceNow, which, as Mike mentioned, is what we use for our self-service platform. That has a number of things related to users submitting tickets, as well as how those tickets get approved, who has to approve them, and then how the final actions to then add people to the right groups are taken. So based on that, we need to talk about, okay, here's our flow for setting up a new role with all of these concepts. Don't worry about remembering all of this because there's a lot. So first, say we want to create an admin role that people can access in an account. We have to first create the permission set for it, and then we have to create an IAM policy for admin and then attach that to the permission set, and then we have to assign the permission set to an AWS account to make sure that the role gets created. Then we have to create an AD group for that permission set in that account to make sure that people getting added to that AD group get added to the role in the account. Then we have to create an access profile and identity now for that group so that then people can get assigned to that group. Then we have to take the access profile and all of the other information and put it into ServiceNow for approvals. And then finally, an end user can go and request it in ServiceNow. And if that seems like a lot, you are not wrong. And sometimes it feels like a bit crazy trying to connect all these things together in a sane fashion. And as such, our initial approach was, okay, there's a lot of things together. What if we made a human do all this? No, we just ultimately decided pretty early on that was not going to work at the scale that we have at Red Ventures. Manual work was not going to cut it, so we needed some automation. So we turned to our preferred infrastructure as code provider, Terraform. This seemed like a problem that Terraform could solve for us, and so we thought, okay, how would we design this using Terraform? Our first approach looked at a lot of the stock Terraform providers that you can just download from HashiCorp without doing any sort of custom code. And those have a lot of benefits, but they also had a number of drawbacks. So some of the benefits is a lot of these just work right out of the box. You don't have to do anything other than some configuration, some credentials, and you're good to go. They integrate directly with the various resources. So AWS, the AWS Terraform provider, talks directly to the AWS accounts and provisions resources directly. There's also an Active Directory provider that talks directly to Active Directory and a number of other providers. All of the providers also have validations, so you can say, these are the values that you need for these inputs and ensure that with a reasonable guarantee that those values will then be accepted by the various integrations like AWS, ServiceNow, etc. However, the drawbacks were that the AWS provider and a number of the other providers are a little bit too granular in how they're constructed. And to be fair, this is also on AWS's end in that you can't create resources for more than one account or region at a time easily. And also, it requires lots of credentials. The single sign-on service is integrated directly into the organization management account in AWS, which means that credentials, it requires a lot of extra things and requires Terraform to have direct access to do all of those things, which means that we would need to set up additional credential management, and that was going to be a lot of pain. There also are not necessarily enough stock providers to do what we needed to do. There might be one for identity now. I didn't check. There is kind of a community one for ServiceNow, but our ServiceNow setup's a bit custom, so it may not have worked right out of the box. And we also did this kind of approach on a previous project that did some private networking connectivity between accounts using the stock AWS provider. And it very quickly became untenable. Plans would take 30 minutes to run, and if they planned successfully at all, it very frequently ran into rate limits. And ultimately, we didn't want a repeat of that because that quickly became a pain for most people that worked with it. And so then, given that the stock providers aren't going to work, we went and looked at other products at Red Ventures that used Terraform that kind of solved similar problems or had to address similar things. And one of the things we came upon is a project that we have at Red Ventures that automates a lot of our transit gateway connectivity between AWS accounts. At a high level, the way that flow works is you have a GitHub repo, you make a pull request to it. That pull request uses the stock AWS Terraform provider to upload a JSON specification to an S3 bucket, so sort of a pseudo API in that regard. And then an AWS Lambda responds to that upload and then does things behind the scenes. So we thought, okay, this approach might work pretty well because it is a lot faster. It has a lot of benefits that counteract some of the drawbacks of the previous implementations. Some benefits and drawbacks of that approach, though, it was a lot more self-service in that it didn't require a ton of Terraform knowledge and a lot of interconnecting services. It could connect things across accounts easily. There was no direct talking of Terraform to multiple AWS accounts. It only talked to the one S3 bucket. But the drawbacks were that validation was tricky. Since it was just a JSON file, it became a lot harder to validate certain inputs. Also, approvals were tricky because everything was in one repo, and all of that had to be approved by a single team, which led to bottlenecks when people needed changes. Also, the feedback loop wasn't great because all of this work was happening behind the scenes, and very infrequently would developers be able to know if their changes had been applied successfully internally, because all of it happened after the S3 object got uploaded. And so after looking at both of these solutions, we decided, well, what if we could get the best of both worlds? And so that led us to, why don't we write our own Terraform provider? I'd done that before. I had done work with the AWS Terraform provider, and we are a Go shop normally, so Terraform providers seemed like a pretty natural thing to write. Our final design, like Mike mentioned before, is we have a GitHub pull request that uses the Terraform cloud with our custom provider to talk to our custom API, which then orchestrates a step function workflow behind the scenes to talk to all of the different third parties that we needed to talk to. So I mentioned before that the stock providers are too granular and only operate on specific accounts. So let's talk about that for a minute. Red Ventures has almost 400 or more than 400 AWS accounts, and that number continues to grow, which is insane. And we were trying to figure out, okay, how do we figure out the issue of assigning permission sets to specific accounts? Because that has to be set somewhere. And we didn't want to have to maintain a hard-coded list of 400 account IDs, because that's a ton. And then that would require manual adding and removal when accounts get destroyed or created. And so we came up with a solution of dynamic account filters, which allowed us to set ranges of selection for multiple accounts, and it made it a lot easier. So I'll give a little demo of what that looks like. Say we have like the following accounts, and then with this code snippet, with this filter, each filter has a field and then a number of values, and those use basically Boolean logic behind the scenes to determine which accounts get included or not. And so you can filter by account ID, which made a lot of sense. That's kind of the basics. You can do multiple account IDs, so that works pretty well. You can also do account name, which supports pattern matching. So you can do things like get all production accounts based on the account name. That works pretty well. You can do it based on the account tags, which we use those to note things like the business vertical that they're under. You can also use the organizational unit IDs, which are useful for, one, applying things across the whole organization, but two, doing things more selectively. So if we have a org unit for specific compliance framework like HIPAA, then we can select all of the accounts within that particular unit. And they're also exclude filters, so you can then get more fancy with your include and exclude logic to include a range of accounts except for a specific one. So we figured that part out, and then we started looking at how do we make this self-service, because the problem with the other project that we mentioned before is that all requests had to go through a central team, which led to a lot of bottlenecks. And we figured out how to set up sort of delegated management of resources in Terraform. This uses at its core the GitHub feature called code owners, which allows you to require approvals for certain files to go to a certain team. And what we were able to do is use Terraform provider configurations and set things like, in the provider config, set things like, here's the account filters that are predefined in this provider configuration. Here's a prefix so that names in one configuration don't conflict with names in another. And then what we were able to do is pass that provider config to a subfolder, which we then set up in code owners to go to a separate team for approval. And that way, teams can somewhat choose their own destiny with their specific range of accounts, and they aren't blocked by us having to approve all their stuff. And that's worked pretty well so far. Lastly, I'm going to turn it over to Yates to talk about how we solved some of the security and compliance issues with this approach as well.
Thank you, Austin. As he said, my name is Yates Spearman. I am a platform engineer who's been working on this project with Austin and Mike. Apologies in advance if I doze off during my own talk. I've got a newborn at home, and sleep deprivation is a very real thing in my life right now. But I'm going to talk through really some of the security and compliance hurdles we faced when building out this solution for Red Ventures. So because what we were building was a one-size-fits-all solution that really had the ability to grant access to the keys to the kingdom at Red Ventures, there's a couple really big questions we had to wrestle with early on. The primary one being, how can we even delegate access at the scale that we're at? With us being a team of 3 people working across several hundred AWS accounts, there's no easy way for us to know who should have access to a particular account, or even for us to know who should have access to a particular account. So in trying to answer this question, among others, we started to meet with the different teams that would be customers of this product, different platform engineering teams, business verticals, individuals responsible for several AWS accounts, and really started to talk through what this solution needed to do. One of the benefits that came early on from this solution is that we realized because Red Ventures maintains a concept of account ownership, essentially the individual who is responsible for an AWS account from a security perspective, we could actually lean on an existing table we had with these mappings to be a part of our approval process for the roles that we defined. So in meeting with the teams, we made sure that the data we had was fresh, since it would be essentially what gate kept access. And we were also able to define a standard set of roles that would really solve 95% of our use cases at RV, and an approval flow for those roles. So we created a few roles ranging from read-only and support access all the way up to administrator access, and an approval flow for those standard roles that started with an individual's manager, really just making sure they're not clicking buttons trying to get access to random things, which happens more often than we'd like to admit. Then it went to that account owner because they were an individual who should really have the context to know who should have what level of access in an account. And for elevated roles, such as the administrator role, it also went to the tech VP aligned to that account, kind of adding another barrier of access to those elevated roles and ensuring we maintain a minimally permissive model wherever possible. Another thing that came up in these conversations is that we realized while we could solve most people's use cases with these standard roles, we needed our solution to be extensible for different teams that these standard roles didn't work for. Things like our data science team that do things across the org, our security ops teams, and different compliance-related teams that these standard roles just weren't appropriate for. So like Austin touched on, we're able to delegate these people their own folder in our automation code base and allow them to define not only their own custom roles to be applied in their accounts, but also in a custom approval workflow using any combination of individual AD users, AD groups, an individual's manager, account owners, and tech VPs, really giving them the flexibility and granularity to define whatever they need for their environment. And through the use of code owners, we could also make sure that we maintained separation of concerns so they could do what they needed for their environment, and we could work on maintaining those standard roles to solve most people's use cases. There are also a few compliance challenges we ran into when building out this solution. With Red Ventures as large as it is, we operate across several compliance frameworks already, such as PCI, HIPAA, LGPD in Brazil, and the company is very growth-oriented. So anytime we come into the office, there's a very distinct possibility that we'll be told, hey, we work in this highly regulated industry now. And we wanted to be as forward-facing as possible in designing the solution so we didn't have to make any large adjustments later on. So we started meeting with not only just the developers on these teams, but their compliance teams as well, gathering requirements and making sure that in our initial phase of building out the solution that we met all the needs they had. We built out different logging solutions, maintained separation of concerns, and really designed this with auditability in mind. We built in real-time audits for user and account access, and actually made it available via Slack. As a group of individuals who have been through audits before, we know there's a lot of data to gather, and the more easily and readily available that data is, the happier your compliance team is. As well, these teams also had a lot of existing workflows for getting access to their regulated environments, and we needed to make sure that our solution integrated with those out of the box so that it would be a drop-in replacement for them. And when it came time to roll this out across the organization, there was as little resistance as possible. There are a few things we learned along the way from taking this approach. One of them being because we engaged with our customers really early and often, we were able to maintain a very consistent vision for what this product would look like throughout the whole implementation phase. Obviously, a few things changed here and there, but from the beginning, we really knew what this product needed to look like and what it needed to do, and it made it really easy to estimate how much time it would take us to build it out. As well, we learned that by solving our edge cases first and working with those compliance teams, when it came time to solve really the 95% of use cases, a lot of the functionality we had was already there. So by solving those edge cases first, we were able to build out a more well-rounded solution. And really, we learned that while people say don't reinvent the wheel, sometimes there's a good reason to do so. And in this case, we thought we had a good reason, so that's why we built our own Terraform provider for this. Here is our speaker information. If you'd like to contact any of us after the conference to chat about this, we love to talk about what we do from an engineering perspective. And other than that, enjoy the rest of your HashiConf. Thank you.